All right, lesson 9.1. Okay, this is the beginning of our chapter 9 unit. This will be talking about rational functions and different types of functions there too as well. So, first thing I want to do, you want to fence in an area in your backyard that is 60 square feet. What are some possible dimensions? So, if we do this and you think about a fence, okay, length times width. So we could, let's say we could have a 1 by 60, okay, 2 by 30, 3 by 20, 4 by 15, and we can go on and on. Okay, the thing what I want us to notice is if this is our length, this is our width, okay, as that length goes up, the width is going down, okay, and that is an example of an inverse relationship. Okay, so in this lesson we're going to talk about direct, inverse, and joint variation. Okay, so for this case, to figure out the area of something, you would take the length times the width. So we'll say length is x, width is y, and in this case it would equal that 60. Okay, now anytime that x went up, y would have to go down. So if we say divide by x, and you get y is equal to 60 over x. Okay, so again, as x went up, y went down. Okay, so and then the 60, that is the constant of variation. Okay, and that's the big thing when it comes to this lesson. So what we need to know. Okay, we're going to write and use direct, inverse, and joint variation models. Direct variation, what you need to know now or memorize is y is equal to k times x. For an inverse variation, you need to memorize y is equal to k over x. And then for a joint variation, z is equal to kxy. Now, x, y, and z, those are going to represent your variables. What you notice in all three of them, you have that k. K is representing the constant of variation. Now, and the types of problems we're going to see in this lesson is I'm going to give you what x and y is, and you need to figure out that constant variation and determine what type of variation it is as well. Okay, direct, inverse, or joint. So let's go ahead. Let's just get to the first examples. Do x and y show direct variation, inverse variation, or neither? Okay, now when we do this, what you need to do is you just need to solve for y. Okay, get y by itself. Then from there, you're going to see what type of variation it is. So if we look at that first example, in order to solve for y, you'd have to divide both sides by x. Okay, so then we get y is equal to 4.8 divided by x. Okay, now if you noticed, okay, direct variation, you're multiplying. Okay, inverse variation, you're dividing. Okay, now in A, if you just look at it initially, x times y equals 4.8, you could think direct variation right away, but you need to remember, you need to solve for y. And when we solve for y, it was 4.8 divided by x. So in this case, it is representing an inverse variation. Okay, now if we go to the next one, okay, we got x is equal to y divided by 1.5. You see y divided by that, it's throwing you off. Okay, you initially when you look at it, you think inverse variation, but remember you need to solve for y, and in order to do that, you'd multiply both sides by 1.5, and you get y is equal to 1.5 times x. Okay, and there we're multiplying. Okay, so this one is actually a direct variation. So what it comes down to, solve for y, then determine if it's direct or inverse. All right, so the variables x and y vary inversely. Use the given values to write an equation relating x and y, then find y when x equals 10. Okay, so the first thing we need to notice is that we're dealing with an inverse. So y is equal to k over x, because that's our inverse variation. Then from there, what we're going to do is you're going to take those values and plug them in. So what we're going to get is 6 is equal to k over 1.5. And then solving for k. You got to solve for that constant of variation. Again, it's a constant, so it is a value once you figure out what x and y is. So to solve for k in this case, you're going to multiply both sides by 1.5. 6 times 1.5 is 9, so 9 is equal to k. And then finally, taking that constant and plugging it in. Okay, so our equation in this case will be y is equal to 9 over x. Okay, so that is our answer for A. Now, part B, then find y when x is equal to 10. So what we're going to do, we're going to take 10 and plug it into x. So y is equal to 9 over 10. And there's no simplifying to do, so therefore y is equal to 9/10. Okay, so the next one, variables x and y vary inversely. So again, y is equal to k over x. And then taking those values, we're going to find that equation relating x and y. Taking those values, plugging it in. So we're going to get 6 is equal to k over 5. In order to solve for k, you're going to multiply both sides by 5. And you end up with k is equal to 30. Okay, again, taking 30, plugging it into k, and you end up with y is equal to 30 over x. So that is our answer for part A. And again, B, then find y when x is equal to 10. So y is equal to 30 over 10, which is y is equal to 3. Okay, now, can't do part B without part A, because in part A, we are finding that equation that is relating x and y. So you need to make sure to find that constant of variation. Now, a lot of people like to stop when they get to there, where k is equal to 30. You need to make sure to put that constant of variation into the actual equation where the y equals k over x. All right, variable z varies jointly with x and y. So right from there, z is equal to kxy. Again, that's one of those things you need to have memorized. Okay, use the given values to A, write an equation relating x, y, and z. Then find z when x is equal to -3 and y equals 4. Now for this one, same idea. We're going to plug in what we know and solve for k, our constant of variation. So it said z is equal to 24. So again, 24 goes into z, 3 will go into y, 4 will go into x. So it's equal to k times 4 times 3, which will be 24, is equal to 12k. Dividing by that 12, you get k is equal to 2. And again, finally, plugging that back in, you get z is equal to 2xy. Okay, so that's part A. Part B, then we're finding z. So z stays its variable. 2 times x, which is -3. And when y is 4, just multiplying that out, and we get -24. Okay. So again, make sure you don't stop when you find k. Plug it back into the relation. Okay, another one. Variable z varies jointly with x and y. So again, z is equal to kxy. Okay. And then let's go ahead and let's plug that in. We get 144 is equal to k times 2 times -54. Or 144 is equal to -108k. Divided by that -108. Okay, and that will simplify down to -4/3. Okay, taking that value, plugging it in. So our answer for A, z is equal to -4/3 xy. And for B, figure out what z is when x is -3 and y is 4. So z is equal to -4/3 times -3 times 4, which will give us 16. Okay, -4/3 times -3 will be 4. 4 times 4, we get that 16. Okay, now we're not going to worry about that one. Okay, now writing an equation. Okay, so I could say a bunch of different types of variations, and you need to come up with those variations. Okay, so the first one, y varies, right there. Y varies is telling us y equals. Y varies directly with x and inversely with z squared. Now, what you need to remember is you always have the constant of variation. So in every single one of these, we will have k. Okay, so don't forget k. Okay, so and k will always go on top. And if it's saying directly, okay, you're going to multiply it with your constant of variation. So directly with x. And inversely saying division, z squared. Okay, so anytime it says directly, it will be in the numerator. Inversely will be in the denominator. Okay, for b now, y varies, so y equals inversely with x cubed. Okay, so a lot of people would say 1 over x cubed, but remember, it's k over x cubed. Okay, see there, y varies, so y equals directly with x squared, so kx squared, and inversely with z. Directly on top, inversely on bottom. So directly with x squared, we get kx squared, inversely over z. Deep, z varies, so z equals jointly, and now jointly is saying you're going to take those two terms, okay, those two variables, and multiply them by your constant of variation. So k times x squared y, jointly, multiplying by both variables. And then finally, e, y varies, so y equals inversely with x and z. Okay, so it's varying both inversely with x and z, so they're both inverse, so you got to divide by both variables. All right, so that's writing equations of variations. All right. Yeah, we'll do this. The ideal gas law states that the volume V in liters varies directly with the number of molecules N and temperature T in Kelvin, and varies inversely with the pressure P in kilopascals. The constant of variation is denoted by R and is called the universal gas constant. Okay, so again, we're writing this variation. It says the ideal gas law states that the volume V varies. Okay, so right there, V equals directly with the number of molecules, N, so N will be on top, and the temperature. Okay, so we got NT, and remember, we got to have that constant of variation, which is typically represented with K. In this case, we said R, so RNT over, okay, the pressure, okay, and that varies inversely with the pressure, so the pressure has to go on bottom. Okay, so that is the equation for the ideal gas law. Now, estimate the universal gas constant. So there we're trying to find R. Okay, so it says the volume is 251.6. So 251.6, just replacing V with that, is equal to R. We don't know R. It says estimate the universal gas constant. So R, N is 1, so times 1, times the temperature, which is 288, over the pressure of 9.5. Okay, I'm not going to go ahead and we're not going to solve that, but that is how you would set it up. Okay, times both sides by 9.5 and then divide by 288. Okay, all right, so your assignment is a book assignment. It will be labeled as 9.1 homework. Okay, and this is what it will look like. Tell me what type of variation it is. Okay, and then finding those equations given specific values. All right, if you have questions, make sure you let me know. Otherwise, have a good day.